spend some time talking about relation, how to represent a relation. So let's write the title of this particular section down. It is 3.1 Representing Relations. So let's talk about some of the vocabulary words that you will have to learn today. Let's just review a little bit here of what a relation is. What is a relation? Well, it's actually just a way to represent an ordered pair, right? So a relation is a set of ordered pairs. Now, if you don't remember what an ordered pair is, let's do a quick review. Remember, an ordered pair is made up of the x and y coordinates of a point, right? So this is what we call an ordered pair. And when we have a set of those ordered pairs, we call that set a relation. Okay, so the next word that I want to talk about is the word mapping. The mapping what it does is it will illustrate the linking, basically, of an input to an output, or in this case an x to y. So whatever way you want to say it, that's fine. Remember, we have many ways to say the same thing. We call this input, output. Well, it's actually, might as well just remind you about it. We call this input, output, domain, and range. Okay. The linking of the domain. I'm just going to use the big words here. Domain and range. Don't forget, domain means x and range means y. Vice versa. You know how we can also use x as your input, y as your output. Now, another name for this is also known as independent versus dependent. Okay. So I'm trying to review all the names for you here. So it's illustrate the linking of a domain and range. So for example, if I give you a point like this, 3, 5, that's your input, that's your output, x, y. So on a mapping, what you do is you create an x column and a y column. Here's your 3, here's your 5. You basically draw an arrow from 3 to 5 to link it, and that's what we call a mapping diagram. Now, understand that I'm just trying to, I'll show that example in a minute, but for now, just stick with mapping. Another word that I want to talk about is the inverse relation. Well, just like what it says, inverse. Basically, it's a switching of the coordinate. Okay, so so if I give you 3, 5 once again, and I want you to find the inverse relation of it, all you need to do is switch the x with the y and the y with the x. So now your inverse, so we call it, will be 5, 3. Notice the switching of the x and y. That's what an inverse relationship is all about, the switching of the x and y. So let's go through with a couple examples to show you what it should look like. Let me give you a relation, a set of ordered pairs. Imagine I have the following. Notice how I used, the brace for a relation because it will contain more than one point inside. So here's my first point. 3, 5, 2, 4. Let's try another one here. 0, 4. 3, 7. Okay, I'm just making up random points, and I want you to represent it using a table a graph and using a mapping diagram. So I'm going to go through and show you how to represent each of the point using each of the method I showed you. So for example, if I want to represent this relation as a table, here's a table format. Don't forget, table has x and y. So the x, you just basically pick out all the x, but don't forget, if somehow it's repeated, for example, the 3 is being used twice, so you only need to write it once. And I do want my point to be in a particular order as well, so I'll do it from least to greatest. So 0, 2, and 3. Remind you again, notice that the 2 3's are appearing twice. I only need to represent one time. Well, I'm sorry, not on the table, but you can actually do it on the table here. That's fine. So it's going to be 3. So here we go. 0, 4, 2, 4, 3, 5, 7, 3, 7. Okay, so that's the table format. And on a graph format, it will look like this. Here's your x and your y. Here's your y. Here's your x. 0, remember 0 is horizontal, as you don't move anywhere. 0, 4, so I'm going to go 1, 2, 3, 4. That's my first point. 2, 4 is to go 2 to the right because that's positive, and 4 up. 3, 5, so I'm going to go 3 to the right and then 5 up, somewhere right here. And 3, 7 is going to be way up here. Okay, as you can see that. That's the graphing format, and of course, for a mapping format, this will look like this. Here's the x column, just similar to a table. I forgot to mention that the fact that for a mapping diagram you only need to represent an element one time if it appears more than one time in your table. So for example, notice that on the x side, I noticed that the table has 2 3's. So in my mapping diagram, I only need to do it one time. Okay, that's what I'm trying to say. Here in the y, the 4 appears twice, but I only need to write it one time, and the 5 and the 7. So here we go. Let's go back and do a mapping. I know we have a 0 to 4, so I'm drawing an arrow, 0 to 4. I have a 2 to 4, so notice that there's an arrow from 2 to 4, 3 to 5, and a 3 to 7. That's how you do a mapping diagram. It's very straightforward and easy. All that I need to remind you of is, when you have an element in your relation appears more than one time, you only need to represent it in your mapping, just mapping. I'm sorry about the misunderstanding of the table. Just the mapping. Only write it one time, even if it appears like 5 times. It doesn't matter, because you can use the arrow. You can have arrow pointing from and to different elements. So we keep it at that. Let's try to do another example right now. A quick one, just to show you. Here we go, another one. Here's another relation. Okay, this time, I just want to do a table and a mapping. The graph, as you know, is you just have to plot these points. So here's the table format. You have your x and your y. Your x will be -1, 0. I have 2, 3. I have 3, 3, and 4, 6. For the mapping, I will have my x and y column. Very similar, like I said, very similar to your table. However, you only need to represent an element that appears twice or more one time. So in this case, it's -1, 2, 3, 4. I'm seeing it one time, right? So I have to write everything. Here, I'm seeing 3 appearing twice in the y, so I only need to write it one time. I have 0, 3, and 6. So let's start mapping this. -1, 0. I have 2, 3. I have 3, 3. And I have 4, 6. Okay. I want you to, I'm actually preparing for the next lesson anyway, so I want you to go ahead and compare the two very, very carefully. If I'm going to be doing a graph, might as well do a graph for you here too. Let's just kind of squeeze this in. negative 1, 0 is right here, 2, 3, 3, 3, and 4, 6 right there. Okay, I want you to take a look at this very carefully between the two relation. Notice the difference between the mapping, between the graph. I want you to observe it, please, very carefully. Notice how I have you know, two of my inputs going to the same output versus over here I have this, you know, one single input giving to two different results. So take a look at that, think about it, and then I'm going to talk about the next lesson for the next video. Okay, I'm going to wrap it up right here.